Hello, welcome back to Chapter 5, Section 1, Transforming Quadratic Functions. We're doing the guided practice problems on page 320. In this video, we're doing problems 8 through 13. So that's six problems. For each of these problems, the directions say graph. For the video, I'm going to not graph them because there's 6 problems and I'm going to be okay if you graph them using Desmos. Okay, so you can use Desmos for this section. You can also use Desmos for the other sections. I graph the other ones by hand because I think it's actually beneficial for you to see how the parent function actually moves. But for these, we just want to graph the function, and we've done that already. Okay, so if you want to go ahead and use Desmos to graph it, that is fine. But make sure, because you might have to actually graph some of these by hand on the assessments. All right. Another thing to remember is if you see parentheses, that means that you have a horizontal transformation. So keep that in mind. See, there's parentheses, that's going to be horizontal. All right, so what I want to know, we have the original parent function f of x equals x squared. What do I do with x squared and I end up with 3x squared? Well, I'm going to multiply by 3. Which transformation takes my function, which is x squared, and multiplies it by a number? This is a vertical stretch by 3. And if you graph it, you're going to end up with a graph that is skinnier, more narrow than the parent function. And that's all there is to that one. By the way, you should have your table of transformations nearby. I have it memorized, but when you're doing this, you're probably wondering where I got this from. It comes from this. G of x equals a times x squared, or a times f of x from the generic table. So make sure you have that information nearby if you don't have it memorized by now. All right, I said parentheses mean horizontal, so I know this is going to be horizontal. I don't see a negative, so it's not reflecting, and I'm not adding or subtracting anything inside the parentheses, so it's not a translation. I'm multiplying. That's a stretch or compression. But which one? This 1 over 8 is the reciprocal of my scale factor. So what's the reciprocal of this? The reciprocal of 1 over 8 is 8. So my b is going to be 8. Since 8 is bigger than 1, this is a stretch. Please remember one over b is the reciprocal of b, and b, the reciprocal of this, tells me if it's a stretch or compression. So write that down on a piece of paper and have that nearby when you're doing your homework. Problem number 10. No parentheses. Vertical. This is a vertical stretch or compression because I'm multiplying. It looks like I'm multiplying by 0.25, so my a is 0.25. That's less than 1. So it is a vertical compression by 0.25. Or you can say 1/4. You want to leave it as a fraction. Fractions are okay. Okay, how do I know that? That's because 0.25 is less than 1. Let's go back to this one. For this one, my a equaled 3, and 3 is greater than 1. That's what made it a stretch. Problem number 11, I see parentheses. I also see something outside of the parentheses. So there are two transformations that I have to deal with. Like I said earlier in a previous video, start by working inside the parentheses first. So what do I have here? I got 5x inside. This is a horizontal stretch or compression. Now, my first thought is 5 is bigger than 1, so that means that this has to be a stretch. But before I write that, I remember reciprocals. So 5 is the reciprocal of what? Well, what's the reciprocal of 5? 1/5. So my B equals 1/5. Since that's less than 1, this is a compression. It is a horizontal compression by 1/5. And since I said you can change that to a fraction, you can change this to a decimal. You want to say 0.2? I'm good with that. All right? Please, please, please remember that when you have parentheses, it's horizontal, and when you multiply, so you're going to get stretch or compression, you're finding the reciprocal. That goes back to, and we didn't do it in this video, but remember, like in a previous video where we had x plus a number, that's subtracting a negative. So be careful with that. Now that takes care of the 5, but it doesn't take care of the negative. The negative on the outside tells me that I have a vertical reflection, and vertical reflections go up or down. So it's over, or you could say across, same thing, the x-axis. So the negative flips it upside down. And we're going to talk way more about that in the next section. Problem number 12, I'll move this up a little bit for you. Problem number 12, no parentheses, so this is vertical. I'm multiplying by 4.2, so that means I have a vertical stretch. And I know it's a stretch because 4.2 is greater than 1. Finally, for problem number 13, no parentheses, so everything's going to be vertical, but I have a negative number. If you say vertical compression by -2/3, that will be marked wrong. Please do not say vertical compressions or stretches, or even horizontal compression or stretches, by negative numbers. The negative means it's a reflection. Stretches and compressions, the scale factor is always positive. Okay? So stretch, compression, scale factor is always positive. If you go back and see the table, we always had absolute value bars around it. The negative is going to be a reflection. So after all this, it is a vertical compression, but it is a vertical compression by +2/3. And a vertical reflection over the x-axis. All right, so I think I'm going to be able to find out who's watching my videos and who's just doing the homework by seeing who's going to be doing it this way and not this way. All right, we'll see you in the next video.